Hydronic systems are dynamic. Pressures change continuously in the system as valves open and close, and pumps start, stop, and change speed. With any change in pressure, there is a change in flow through any device, even if the heating or cooling load remains constant. On an air handler, when the flow changes, so does the heat transfer rate. The thermostat picks up that change and attempts to reset the valve for proper flow for the new pressure condition. With any conventional control valve, as pressures change, the actuator strokes to return the valve to the right position to provide optimum flow for the load. This takes time. Typical commercial quality globe valves are especially poor and simply unable to modulate adequately in all flow conditions. With high pressure differential and below 50% flow, these valves tend to behave like two-position on-off valves. This dramatically reduces heat transfer, causing excess flow and low delta T. With pressure-independent delta P valves, flow through heating and cooling coils remains constant, despite the same unavoidable hydronic system pressure variations. Flow only changes when the heating or cooling load changes. Delta P valves instantaneously compensate for any change in pressure internally to maintain a constant differential pressure and flow across the controlled surface. Delta P valves have 100-to-1 rangeability, so coil performance is optimized in both high and low flow conditions. Because Delta P valves don't hunt, and because flow is steady in spite of pressure fluctuations, heat transfer is optimized, flow is reduced, and high delta T is achieved. This graphic illustrates a conventional control valve and a delta P valve installed in the same system on the return side of two coils. The variation in supply and return pressures across the valves is the same. Note that the flow rate through the pressure-dependent valve changes as the differential pressure changes. In contrast, flow through the delta P valve remains constant. Constant flow, precisely matched to the heating or cooling load, optimizes the heat transfer, minimizes circulated water, and ensures that high delta T is achieved at all load conditions. This graphic is meant to show how daily cooling loads change on a campus with varying occupancy and sun conditions. A system is healthy design. Chilled water delta T or higher is achieved at all load conditions. If delta T degrades and is less than designed at any load condition, the system has a virus, low delta T syndrome. With delta P valves, high delta T is maintained at all load conditions. Diversity is also assured in the campus piping loops. Chilled water is moved around the system as required throughout the day as loads change from building to building. Full installed system capacity is available. With delta P valves, the system operates with minimum flow, maximum delta T, and full system diversity. This level of performance cannot be achieved with conventional pressure-dependent control valves. If the system has low delta T and less than full diversity, additional installed capacity is required and more equipment must run to meet the load.